Welcome to a special edition of NASA Science Live focusing on climate change. I'm your host, Tahira Allen. Today, we're diving into the world of extreme weather and how NASA's cutting-edge technology and research are helping us understand these phenomena. This is your chance to interact with NASA experts and have your questions answered live on air. Be sure to drop those into the comment stream wherever you're watching using the hashtag AskNASA. Today's focus is extreme weather. As Earth's climate changes, we see changes in the frequency or intensity of events such as record-breaking heat waves, severe floods, prolonged droughts, devastating wildfires, and intense hurricanes. Understanding the science behind these changes is crucial for our future. Since the Industrial Revolution, human activities, especially the burning of fossil fuels, have led to a rapid increase in greenhouse gases. These gases trap heat, acting as a blanket that's warming our planet and affecting weather patterns. NASA satellites provide invaluable data that are helping us monitor these changes and model what may happen in the future. We are keeping an eye on the questions pouring in online, and we'll be bringing those straight to our experts live on air later on in the show. We'll also have experts in the comments standing by to answer your questions in real time. Let's jump right in. With us now is NASA's Chief Scientist and Senior Climate Advisor, Dr. Kate Calvin. Welcome, Kate.
Thanks for having me, Tahira.
And Dr. Michelle Hawkins, the Program Manager for NASA's Climate Resilience and Community Action. Hi, Michelle.
Hi, Tahira.
Thank you both so much for being here with us. Can you start by explaining a little bit about your roles at NASA? Kate, we'll start with you.
Yeah, thanks. So I'm NASA's Chief Scientist and Senior Climate Advisor. So I play a few different roles within the agency, both with respect to science and climate. I'm an advisor to the administrator and senior leadership and give them information about science and climate. I play a role in connecting within the agency. We have research on climate that happens throughout NASA, and I help bring those people together and ensure that connection within the agency. And then I do a lot of outreach and engagement externally so that people know what NASA is working on and have access to that information.
And Michelle?
Thanks, Tahira. So as a program manager at NASA headquarters in the Earth Action Program, I support projects that help us understand how climate change is impacting communities and how NASA science and data and information can be used to help build resilience to climate change and to address equity and environmental justice issues.
Thank you both. That is really helpful, and we are so glad to have you on today's show. So let's jump right into the topic, extreme weather. Michelle, when we say extreme weather, what types of events are we talking about specifically?
Yeah, so scientists have a really specific definition when talking about extreme weather. We're really talking about those really rare events that we would expect to happen not often, so maybe even less than 10% of the time at a specific location at a certain time of year. But climate change is changing those odds, so changing the odds that we'll experience more of these really rare events. And that's exactly what we're seeing. We're seeing more intense hurricanes, we're seeing longer, hotter heat waves, and more heavy rainfall.
That's really useful context. And so, Kate, to follow up, how do scientists determine that changes in extreme weather events are linked to climate change?
Yeah, thanks. And that's a really great question. So scientists have a number of different ways at looking at how climate impacts things like extreme events. One of the things we do is we can look at observations and see how things have changed over time. So we have more than decades worth of information from satellites, which give us this comprehensive coverage of our Earth and what's happening on it. We have even longer records when we look back through the surface temperature and precipitation records. And what we can do when we look through that is see how there's been changes in events over time, whether the frequency, the duration, or the intensity of those extreme events. We also use things called models. These are computer programs that capture our understanding of the physics and the biology and the chemistry that happens on Earth. And we can use those to better understand the processes that drive changes or project them into the future. And usually when you hear people talk about extreme events, we'll often talk about types of events and how those types of events might change under a warming climate. So we might talk about more heat waves or other extreme events. But there's also people that look into an individual event and how much more likely it might be with climate change. So we can compare worlds with and without warming and see how much more likely was that event to have happened, given that there's been climate change.
Wow, that makes sense. And it's great that we have so much data. As we've been discussing, NASA has been able to observe and monitor these events from the vantage point of space, no matter where they've occurred. And so, satellite data from NASA and other government agencies, like our partners at USGS and NOAA, are really critical to understanding how and why these extreme events take place. As you were just talking about, Kate, how does NASA specifically address extreme weather events, say before, during, or after they occur?
Yeah, so we do look before, during, and after. Some of the ways that we look at these sorts of events are with near real-time data from our satellites. And so we can look before an event and see if the conditions are conducive to a particular type of event occurring. During an event, we can provide information in near real time to decision makers so they understand what's happening. And after an event, we can look at what might happen and has happened, so you can provide that to response agencies to help with recovery. That's just with near real-time data. One of the other things NASA does is we develop models like the one I've mentioned and contribute to understanding. And so before an event, we can actually look into a better understanding what might lead to that event in the future and use that for long-term planning, so we can understand how conditions might change further into the future and help people plan into that long-term future.
And I'll add that we work very closely with our federal partners to help them access NASA data that can be useful in their response missions. So, for example, NASA has a disasters program, and earlier this summer, the disasters program announced a new disaster response coordination system, which provides actionable, timely, and trusted information to agencies and organizations that are actively responding to disasters. And in fact, just before jumping on here, I got a notification that the disaster response coordination system was activated for flooding in Nepal right now.
Wow, that is really great to hear, that we have this new coordination system. And as you mentioned it, for anyone watching that wants to learn more about how NASA advances the science for disaster relief and resilience, you can visit disasters.nasa.gov. So let's talk specifically about hurricanes for a moment. Right now, we're in the middle of Atlantic hurricane season, which is from June 1 through November 30th. We have seen communities affected by Hurricane Beryl, and even here on the East Coast, many communities are currently getting weather from Hurricane Ernesto. Michelle, are more frequent and intense hurricanes linked to climate change?
So, although we don't see a direct link between climate change and landfalling hurricanes, we are seeing more intense hurricanes, especially as they move over the really warm waters of the Gulf of Mexico. So, scientists are also seeing more slowly moving hurricanes. And so some of this science is still happening, still working to understand the connection between climate change and slow moving hurricanes. But I will say that a slow moving hurricane is a very dangerous hurricane because it can dump a lot of rainfall in a location and cause really catastrophic flooding. And we saw this in 2017 when Hurricane Harvey hit the coast of Texas. That hurricane slowed to about 5 miles an hour after it made landfall and dumped historic amounts of rainfall and caused catastrophic flooding in that area.
And you just mentioned we got an alert about heavy flooding, so on this topic of heavy rain, which can sometimes lead to flash flooding events, even in more inland areas. Kate, are these occurrences linked to climate change?
Yeah, one of the things that climate change does is change the water cycle. And as a result, we're seeing more heavy precipitation events. So when rain comes down, we're seeing a lot of it, and that can lead to flooding. And in addition to changes in rainfall, there's also, we're seeing increases in sea levels, so melting of ice caps and And the change in the temperature of the water in the ocean has led to sea level rise. And for coastal communities with higher sea levels, we're seeing more storm surge and more flooding events, even without changes in rainfall. So we're seeing more rainfall, higher sea levels, and both can contribute to more flooding events.
Wow. And, right now it seems we have gotten a little bit of break from the heat waves. But, for the last several months, we have been seeing record breaking temperatures and heat. Kate, can we expect to see more heat waves in the future?
Unfortunately, yes. With increases in global average temperatures, we're seeing more extreme heat events, more frequent, and changes in duration. And these are having impacts on people all around the world.
And if I can add, I think it's important for people to remember that heat isn't just a nuisance. Heat is, it can be deadly. Exposure to extreme heat causes more deaths than any other extreme weather event. And so, yes, we'll be experiencing more extreme heat, but that doesn't mean that we'll necessarily experience more deaths related to heat because we know how to protect ourselves. Our partners over at the National Weather Service issue watch warnings and advisories for extreme heat, so letting us know when it's coming our way. We know that we need to stay cool, stay hydrated, know where the cooling centers are in your area. And then also, NASA has ongoing research looking at how heat is impacting communities and how heat is impacting some communities differently. And so, for example, from the vantage point of space, we can see where there may be areas of tree inequality. And this is information that city planners or state and local governments can use as they're thinking about how to create more cool spaces in their area where they may want to plant more trees.
Yeah, thank you, Michelle, for giving us some of this hope. And, it's great to hear that these are things that we are able to plan for. And on this topic, as we're discussing heat, we do often get the questions, are wildfires getting worse? So let's take a look.
Are wildfires getting worse? Yes, unfortunately they are. We're seeing increases in the intensity and the severity, the overall burned area of wildfires, and the duration of fire across the fire season. And while fire is a natural part of ecosystems, what's really driving this change is we're seeing a lot of changes in our climate. We're seeing increases in global temperature, as well as more extreme weather events, so longer droughts. And so we have these hot and dry conditions, which makes vegetation, forests, and grasses more available to burn because they're drier. And so with these drier conditions and these drier fuels, we're likely to see more fires. And this is happening in many locations all across the world. This can be really detrimental to the ecosystem, but also to human health, where we're seeing people going to the hospital with respiratory issues, and smoke can just travel many thousands of miles with these fires. How can we help? What can we do? One thing that I find really hopeful is that NASA continues to study wildfires around the globe. We have people going out on the land to make measurements. We have airborne campaigns that fly around to better understand wildfires from the air, how it's impacting smoke, where wildfires are burning. And then of course we have satellite imagery, which gives us a global picture of wildfires all around the world all the time. So are wildfires getting worse? Yes, they are. But there are ways that we can all think about this together. And I think just learning about these issues and being able to share that with other members in our community is a way we can all go forward and think about climate change and wildfires.
So, Michelle, we just got a few examples of what NASA's doing to look at wildfires. Could you expand a little bit on those?
Yeah, so as you saw in that video, from the vantage point of space, we can see how wildfires are behaving. We can see how smoke from wildfires impact communities way far away from those fires. I'm reminded of last year, and I think you're seeing this on the screen, where smoke from Canada made its way to New York, and we all remember those really eerie orange pictures of the New York skyline. And I think it was July 8th where New York had the worst air quality in the world. And so we can see that from space. Our partners who do air quality forecasting can use that information and provide forecasts of where and when people will be experiencing poor air quality because of fires. NASA has a Fire Information for Resource Management System, or FIRMS, which provides near real-time information for active fires. And this helps fire managers make better decisions on how to attack fires.
And another thing that really may be on people's minds right now, especially with the release of a recent Hollywood film, are tornadoes. Kate, what does the current science tell us about the connection between climate change and tornadoes?
So smaller scale, short-lived, severe weather like tornadoes, they're actually more difficult for us to assess than some of these larger scale events. But scientists are interested in better understanding changes in tornadoes. And so it's an active area of research. One of the challenges we have is that observations are incomplete. So when you're thinking about something like tornadoes, we often rely on tornado spotters or observations direct of tornadoes. And so we have incomplete information in the past, which limits our ability to draw really, robust conclusions from it. But again, it's something, given the severity of storms like this, it's something scientists really want to better understand. So there is active research looking into whether or not there's a change in the number of tornadoes or the power of tornadoes. There are some emerging studies that show that tornado alley has shifted. And so I think that's an area we really want to better understand, because for people that have never been around a tornado, they may not know what to do. And so understanding if where tornadoes are occurring is going to change, if the frequency, that's something that scientists really want to better understand. And so there is active area of research, but it is a harder for scientists to assess because of the small scales of the storms.
Thank you, Kate. And, Michelle, here in the US, while we're not in the winter months right now, we also see these extreme events in that season as well, with heavy snowfall and blizzards. What can you tell us about climate change and snow?
Yeah, so that's also an area of active research. Scientists are working to better understand how climate change is impacting winter extremes. We do know that we are experiencing and will experience less extreme cold, really cold days. And on those cold days that the temperatures will be milder. So on milder cold days, precipitation is more likely to be rain instead of snow. So while overall we may see less snow, that doesn't mean we should become complacent, because scientists also know that in a warmer climate, we'll still experience those really impactful snowfall events that we experience now. So the ones that kids get really excited about because it's going to close schools, but also negatively impact our transportation systems and can be really deadly, we'll still experience those events even in a warmer climate.
Well, thank you both so much for this fantastic introduction to extreme weather. We have a ton of questions coming in from our viewers online, so let's get to some of those. And remember, if you are just tuning in, you can submit your own questions for experts to answer live on air by using the hashtag AskNASA or dropping that question directly into the comment stream wherever you're watching. All right, let's jump right in. Our first question is from Jan M on X, who asks, can you imagine what the extreme weather will look like when or if the Earth reaches 4+ degrees Celsius at the end of the century? Kate, why don't you take that one?
I think I can take that one. Yeah, Taira. And I guess before I start, for those that aren't familiar with how climate scientists think about warming, that 4 degrees Celsius might not sound familiar. One of the things that we do is we look at how much climate has warmed from the late 19th century. So from, looking compared to 1850 to 1900. And so we know today is about 1.1 or 1.2 degrees Celsius more than that. So a little more than 2 degrees Fahrenheit. And so when you're talking about 4 degrees Celsius, that's warming almost 3 degrees Celsius more than where we are now. Warmer world than today by a lot. And so one of the things that scientists do is we use climate models like the ones I mentioned earlier to better understand what a future climate might be. And what we can do is look at, different projections of emissions and how much warming that might cause. And then from those different warming worlds, look at how that might impact things like extreme events. So there are a lot of studies that look at how will extreme events change in a world that's 2 degrees warmer than before, 4 degrees warmer than before. And we can actually look at the changes in frequency or intensity of different events. And I think this, one of the things you'll see is more heat waves, more heavy precipitation events, and declines in Arctic sea ice. And so we can see one of the things that scientists track is, how much ice do we have in the Arctic in September, which is when it's at its minimum at the end of Northern Hemisphere summer. And we'll see less and less ice over time with that, depending, and more, nearly ice-free days in the future, more of them, the warmer the world gets.
Thank you, Kate. And the beginning of this show, we've talked a lot about what extreme weather is looking like and how it is getting more extreme. And so my next question, Hamsman97 on Twitch asks, what is the biggest thing that the world could do to slow down climate change? Michelle, do you want to take this one?
Sure. So reduce our carbon emissions. We know that the more carbon dioxide in the atmosphere and other greenhouse gases, we know that they're warming the earth. And so reducing those emissions will help reduce the impacts that we'll see in the future. And I don't know if Kate wants to add to that.
Yeah, I mean, the number one driver of climate change is carbon dioxide. The second is methane. So those are both greenhouse gases. And if we want to slow the rate of warming or even stop warming in the future, we need to reduce those emissions.
And I have a follow-up question, for you, Kate. 24/7 Live Skies on YouTube asks, didn't this all happen many times over again? With the 26,000 year cycle we've been going through for millions of years.
So there are changes in climate, natural changes in Earth's climate that have to do with, the tilt of the Earth, how far it is from the sun. But those happen on very, very long time scales, tens of thousands of years. What we're seeing now is very rapid changes over the last 150 years, and it has a different signature, these changes. So in scientists, we can look at observations, we can look at what changes, and the kind of warming we're seeing now is different than before because it's not from a change in the amount of sunlight coming in. We can measure that, we can study that. It's from a change in greenhouse gases, so there's more heat being trapped and less heat leaving the Earth's surface and going back into space. So we're getting a warming that's due to trapping of heat, and it's happening very rapidly. And that rapid means it's harder for ecosystems and people to adjust because it's happening so quickly.
And, talking about adjusting, Michelle, we have Sani on Twitch who asks, what skills should we focus on learning or solidifying to help with the issues arising from climate change?
I love this question. I'm really encouraged by how universities now are really encouraging interdisciplinary studies. So, we need to learn about how the climate is changing. We need to also learn how people are responding to those changes. We need to learn, what new technologies and science needs to happen for us to adapt moving forward. And so I think there are a number of opportunities to learn more about this topic and different types of things that need to be learned as we move forward.
That's great, and that's really hopeful. So, Kate, we have Michael Martin Dillon on YouTube who says regarding climate change, isn't it largely past the point of no return? Would you say that? No.
Well, how much warmer it gets in the future depends on future emissions. So, Michelle talked about greenhouse gases are driving the warming that we see now. How much warmer it gets depends on how much more we emit in the future. So we have different alternative futures that we could achieve depending on emissions. Everything from keeping warming at roughly the rates we have now to much warmer worlds, and it all depends on emissions.
Thank you. And Michelle, I have my next question is for you. We have Glendon Nielsen on YouTube who asks, can you explain the difference between climate change and global warming? Is there a difference?
Yeah, and I might pop this over to Kate as well. But, when we talk about global warming, we're talking about the average warming that the Earth is experiencing. Climate change is a bit more specific in the different changes that we're seeing in our climate. And so depending on where you live you may experience different changes in your environment.
Yeah, and just adding on that, I will say it's become, those terms are often used interchangeably in common language. So you might hear either of them, and they're both trying to capture this, last 150 plus years where we're seeing rapid, warming due to greenhouse gases. But as Michelle said, climate change is broader than just temperatures. It also captures changes in rainfall and all these other impacts that we think about.
Mm-hmm. And Kate, we have a viewer on Twitch who wonders, would there be a time where heat waves are so unusual that they become the new norm of climate?
I mean, that's a really interesting question. I think what we know is that you'll see changes in the frequency and the duration and the intensity of these heat waves over time. How much more you'll see depends on how much warmer the world gets as a whole. And, as Michelle mentioned earlier, there are steps we can take to adapt to some extent to those heat waves, but they are incredibly impactful to people now, and could be in the future as well.
And Michelle, I know you work a lot with communities and how, they deal with the climate change and things like that. We have Ryan on YouTube who asks, what is the future outlook if current climate trends continue? So, would love to hear that, not only from a science standpoint, but us living in this world. What do you see from that?
Yeah, so if current climate continues the way it is, we'll have to adapt a lot more. And that means that what we're doing now definitely isn't enough. And we already know that we could be engaging communities more and having more community voices in these discussions, so that adaptations that are being made are appropriate for the location and the communities involved. And that's something that we're doing more and more and more of here at NASA, in particular. In the climate resilience program that I manage, we had a solicitation that we released earlier this year, looking for research that directly involves communities. And so I'm really excited about what we're going to get out of that work.
That's great. And Kate, following up on that as well, with what on what the current models and the data are showing us, are there any near-term predictions on what we can expect maybe 5, 10, 20 years from now?
Yeah, this is an area that a lot of the climate science community looks into is, how much warmer will it get on different scales? And as I mentioned, how much warmer it gets in the long term really depends a lot on how much more emissions we have. So we look at different ranges of what greenhouse gas emissions might look like in the future. But when we bring all of that together, the studies show that we'll see continued warming in the near term, reaching 1.5 degrees Celsius, probably in the early 2030s. But how much warmer beyond that depends on us, depends on future emissions.
And I have a great question for the both of you. Michelle, we can start with you, but we have a user on X who wants to know, how are you as climate experts, feeling right now about the future? How do you keep up hope?
Yeah, I'm happy to start there. And I think I'm feeling hopeful. As Kate said, we have options, and the options are up to us. There are decisions that we can make that contribute to the future that we want to have. So, making choices that reduce our greenhouse gas emissions is where I'm leaning. And so, as an individual, there are things we can do, like, there are plenty of options for electric cars. We can reduce the amount of red meat we eat. As Kate mentioned, methane is a huge source of emissions, and we know that cows are a big part of that. So there are things we can do to change our diet. There are things we can do at the community level, at state and local government level. Here at NASA, again, we're doing a lot to understand how the Earth is changing, and the adaptations that we need to take. So I'm just really hopeful for all of the options before us, and just knowing that we have choices to create a better future for ourselves makes me hopeful.
Yeah, I mean, I think, climate change is clearly presenting challenges to people all around the world, and we've all experienced extreme events. And they're no longer, abstract things that might be coming in the future. They're things we're experiencing now. Michelle mentioned wildfire smoke. I'm from the northeastern part of the U.S. This was the first time I'd ever breathed in wildfire smoke in the Northeast. We are experiencing those, and they do present challenges. But I think for me, someone told me once that science is hope. And I think for me, when I think about this, we understand what's driving climate change, which means we understand how we can address it in the future. And there are people all over the world that are working on it, and we're continually, learning new things and better understanding our planet.
And, we touched on this a little bit earlier in the show, but for those that might just be tuning in, Michelle, this would actually be great for both of you, but we can start, Michelle, with you. Barbara on YouTube wants to know, what is NASA doing to help humanity prepare for climate change?
Yeah, so the first thing we're doing is understanding how the Earth is changing. So, we have right now about 25 missions, satellite missions, constantly observing the Earth, helping us understand the Earth as a system and how that system is changing, and how the systems within the systems impact each other. And so, one of the major things we're doing is collecting a lot of data and information to help us understand how the Earth is changing. And the other thing we're doing, as I mentioned, is working more closely with decision makers who need to use that information to make decisions on how to protect people from the extreme events that we're seeing, and how to make decisions on adaptations that would be useful in the future. So we are more and more sharing our data and information with communities and decision makers to help us prepare for the future that we're seeing.
Yeah, and
Thanks,
just
Michelle.
adding to that, as Michelle mentioned, we're helping with understanding so people understand what's happening in their communities and can use that information to plan for the future. We use our models to do projections into the future so you can understand what the different potential futures might look like and how you can prepare for them. And we provide that information publicly so people have access to it, so they can both understand what's happening and also take steps to address the challenges in their communities. And as part of that, we opened an Earth Information Center about a year ago. And there's a couple of parts to it. One is an in-person space. So if you're ever in Washington, D.C., in the NASA headquarters building, we have a public exhibit where we show some of the data and information that we have, as well as from our partner agencies. So a lot of the other U.S. government agencies that we work closely with to help understand what's happening on Earth. We've brought some of that information together and can show people what we know about Earth and how it's changing. And then we also have information from that online. So if you don't come to DC, you can look from wherever you are at earth.gov and see the information we have and better understand what we know about the planet and what data we can provide to help you respond to changes in your community.
That's wonderful. Thank you both. Our next question is from a viewer on Twitch. Kate, earlier you talked a little bit about how the climate change and its relationship to tornadoes is an active area of research. This viewer has a question that asks, what effect is climate change likely going to have on tornado activity in the central US, if we had to give a prediction from what we know now?
Yeah, I think, because it's an active area of research, there are studies that are looking at, whether or not tornado outbreaks are becoming more frequent. So there are people looking into that specific question. And then whether there's a shift in tornado alley. So there are some emerging literature on that the tornado alley has shifted eastward. But I think it's an area we want to better understand so that we can make those predictions. And, our partner agency, NOAA, has a severe storm prediction center, and they work very actively on this to try to give the best predictions they can about tornadoes. And so we're trying to help them understand it. One of the things we can do, so I had mentioned before that one of the challenges is around observations. We can also look at aftermath of tornadoes and look at things like tornado tracks and use that kind of information from satellite data to understand where tornadoes have been. And that's a way of complementing other observations we have and adding another tool to the scientist toolkit as they're looking into tornadoes and how they're changing.
Thank you. And our next question is for Michelle. Michelle, earlier you mentioned that NASA has a fleet of Earth observing satellites. And so now we have Scarlett on Twitch who asks, what is one of the newest weather satellites? And, what new add-ons does it have compared to previous ones?
So I think I'll talk about my favorite newest one, which is PACE. PACE was launched back in February. And what PACE is giving us is really unprecedented in terms of ocean color. We can see from space different types of phytoplankton. We also have better characterization of aerosols. And so as I mentioned earlier, talking about wildfires and smoke, we can see the different types of aerosol within the smoke plumes. And we can see how there are connections that perhaps we didn't see before. So, how wildfire smoke from one area is transported again really, really far away from that fire, but could become nutrients for different phytoplankton, leading to harmful algal blooms. And so we really have an opportunity to see the Earth in a way that we haven't before. And so I'm really excited for the PACE mission. PACE stands for Plankton Aerosols, Clouds, and Ocean Ecosystems.
Thank you. I actually have a great follow-up from Mia on YouTube who asked about phytoplankton and wants to know your thoughts on their importance in climate change.
Yeah, so again, with PACE, we can understand phytoplankton and their environment, and different types of phytoplankton can lead to what's called harmful algal blooms. And these are really dangerous areas that can impact fisheries, they impact beaches. Sometimes there are beach closures due to harmful algal blooms. And so, again, PACE is giving us an opportunity to really study phytoplankton in a way that we haven't been able to before.
And Kate, I know this might be a loaded question, but do you have a favorite Earth mission, Earth observing satellite, or maybe one you'd just like to highlight right now? We don't have to call it a favorite.
Yeah, I was thinking about that as Michelle was answering. I have lots of favorites. And I would say I will highlight two more in addition to what Michelle just mentioned.
Okay.
First of all, PACE is great and really excited about its data. The other two I'll mention, one is called SWOT, the Surface, Water, and Ocean Topography, which is also studying the ocean. So it's looking at how oceans mix, or how the water moves on the surface of the ocean. And that's really important because oceans absorb a lot of heat and carbon. But one of the other interesting things that SWOT is doing is it's going to look at inland water. And so it's going to give us the first global survey of water running through rivers and lakes. We use a lot of water to water our crops or for energy production. And until SWOT, we would rely on things like stream gauges. And so we could measure water in an individual river where we had a gauge, but we didn't have a comprehensive view of how much water we had available or how that was changing. And so SWOT's really going to change that. And then my second one, just because I don't want to just pick one, would be Tempo, which we launched maybe a year ago. It's looking at air pollution over North America, and it's doing it at a neighborhood scale at an hourly rate, so we can actually understand what's driving changes in air pollution and then provide that information to local decision makers so they can take steps to change and improve air quality where they are.
That's wonderful. So, we've got such a fleet of satellites looking from so many different angles, at this Earth. And one thing that I think we might have seen in the news, but we have Sven on Twitch who's asking about it. He says, we've heard about the Gulf Stream stopping or reversing or changing directions. Is that really a possibility, or have other theories disproven that idea? Kate?
So this is also an active area. I think what I'll talk about, usually when I hear about this, people are talking about the AMOC, or Atlantic Meridional Overturning Circulation. So ocean circulation that moves air around on the Atlantic. And if there was a big change in that, it would have pretty severe impacts on weather because it is carrying warm air and moving air around. So scientists are looking into this. I think it's an active area of research. I think it's something that that would have impacts if it happened, but I think the likelihood of it happening is perhaps different.
Thank you, Kate. And Michelle, our next question I think would be great for you. It is Dion Kreif, Emmanuel, on YouTube, who asks, how is NASA helping to develop more sustainable practices in industries, heavily impacted by climate change, like agriculture or energy, things like that?
Yeah, so again, by sharing our data and information. So one thing that comes to mind about building sustainable, in particular sustainable buildings, is we have to think about our own buildings when thinking about climate change. And so we have projects that help us understand how climate change is impacting um, uh, the towns and around the locations of our buildings, and then sharing that information with nearby communities, because we know that climate change doesn't care about our gates. And so the more that we can do to build resilience for NASA centers and share that information with communities, the more we're all building resilience together.
And maybe I
Thank
could
you,
just
Michelle.
add to that.
Yeah.
One of the other things, so a lot of people probably think of NASA. When you think of NASA, you think of astronauts and exploring space. And one of the things we do, we have to think about how we can make sure that astronauts have clean air, clean water, and food in space. And a lot of the research we've done into that also has benefits on Earth. So we're able to produce food more sustainably, or water filtration systems. Some of the technology we've used on the International Space Stations now used on Earth to provide clean water to places where they didn't have it. With crops, we actually grow crops on the International Space Station, and we've done a lot of work into LED lighting and fertilizer that can also be used here on Earth. So that's one of the other things we do when we think about how do we send astronauts into space and make sure that they have air, water, and food. We also think, can we use those technologies for people that are living here on Earth?
It is very cool. Thank you for adding that, Kate. And I have a good question, a follow-up question for you. B BR on YouTube asks, how do we know what the weather was like hundreds of years ago? You've talked about the models and the data that we have that we built from it, but with regards to extreme weather events, when we maybe didn't have all these satellites in place, how are we measuring that?
So we have different ways of doing that. So first of all, from direct observations of things like temperature and precipitation and other events, we have, several decades worth of satellite information. So NASA's got more than 50 years of satellite information. From surface weather stations, we have information back to like mid 1800s, 1850 to 1880s, about when you start to get enough data that you can actually look at global temperatures from surface data. And so we can look at those direct observations from surface measurements starting back then. And then if you want to look further back in time, we have two different ways of doing that. One is we can use proxy records. So we can look at ice cores and tree rings, and they'll tell us about the climate of them when the ice was formed or the tree was growing. And so we can use that to extend our records even further back. And then we can use models to fill in the rest of the information using the observations we have, as well as our physical understanding of processes. We can get a more complete picture by looking at the modeling information.
Thank you, Kate. And so I have a follow-up. We were just talking about satellites. We have a viewer on Twitch who wants to know, what are some of the most promising advancements in satellite technology that NASA uses to monitor and mitigate the impacts of climate change? This is one that, would love to hear from both of you on. I know you both have favorite Earth satellites. And so we can start with you, Michelle, and then hear from Kate.
Sure. One thing that comes to mind is a mission that we're flying right now called EcoStress, and EcoStress is on the International Space Station. And a really unique project that's happening right now is by using data from EcoStress, we're able to see where there are hotspots within cities. So we talked about extreme heat and how dangerous heat can be. Well, from space, I'm always amazed at the things that we can see from space. We can see within cities where there may be hotspots. And so some cities are using this information to paint reflective paint on different streets and in certain hotspot areas. And they're seeing that they're able to reduce the heat in those areas. And so I think that's just one really promising example of how we are helping to, again, share our information and help build climate resilience.
Yeah, and I'll just add to that with another instrument that's on the International Space Station called EMIT. EMIT was actually designed to measure mineral dust. So mineral dust is these fine particles. Depending on the color, they either reflect or absorb sunlight. And so, climate scientists wanted to better understand the distribution of mineral dust so they could better understand what its contributions were to warming or cooling. But the science team just realized that they could also measure and observe methane from space using the same instrument. So they're now been using EMIT to identify methane superemitters. And methane is a very potent greenhouse gas. So knowing where those emissions are coming from is really important in understanding how to address and respond to them.
Thank you both. And so earlier on in the show, we talked a little bit about what climate change means, the difference between that, or if we say global warming. We have Richard on Twitch who asks, does climate change also mean extreme cold? Michelle?
So, as I mentioned earlier, scientists are still working to understand the connection between extreme winter events and climate change. So, but we do know that we are experiencing less cold days, and that on those cold days, the temperatures are milder. So we do see that connection with climate change. But I'll reiterate, as I said earlier, we shouldn't get complacent because we are still going to see really impactful snow events, even in a warmer climate.
And our next question is from Hosier48 on Twitch, who asks, do you see climate change on other planets? Kate?
Yes, so we do study the changes in climates of other planets, and we can learn something from those planets about Earth. The drivers are very different. So I'll just give an example of Venus. Venus has a very high concentration of carbon dioxide, and so it's much, much warmer than it would be without that. And so we see the greenhouse effect on Venus, and we've learned from Venus about things about Earth. The drivers are very different. So on Earth, the increase in greenhouse gases are coming from human activities. On Venus, it's natural processes, but they both have the same effect on temperature in that they're increasing the temperature of the planet itself.
And I have a fun follow-up for you. A viewer on Twitch asks, who has the wackiest weather then, on Earth or Mars?
Oh, I don't know. I mean, I think you might need to define wacky.
That's not my area of expertise either. I don't know.
Yeah.
That's funny. Well, maybe one of our experts in the comments can throw some comparisons down in there. Thank you. So our next question is going to be from Jim Bode on Twitch, who asks, how does sea ice melting raise the sea level? So, doesn't the ice displace the amount of water it contains? Kate?
Yeah, so when we talk about sea level rise and ice melt, we're talking about ice sheet melt. So ice that's over land, when it melts, so Greenland, Antarctica, glaciers, when those melt, they add more water to the ocean. So when we're talking about the contribution of ice to sea level rise, we are talking about ice over land. And that is one major component of sea level rise we're seeing, is that as you melt ice on Greenland and Antarctica, and you're seeing some observations of Antarctica right now on the screen from one of our satellites called GRACE, and then its follow-on mission, GRACE Follow-On. So that's contributing more water to the ocean. The other component of sea level rise that you'll hear people talk about quite a bit is what scientists would call thermal expansion. So as water gets warmer, it takes up more space, and that contributes. But when we think about sea ice melting, it's not adding volume to the ocean. It does change the salinity. It changes the reflectiveness of the Earth's surface. If ice is brighter than water might be. But when we talk about ice melt and sea level rise, we're talking about ice that's over land melting into the ocean.
And we just saw those GRACE observations of Greenland. We have a follow-up question from One Fun Panda on Twitch, who asks, will Greenland melt in our lifetime? It's a tough one.
I mean,
Mhm.
there's parts, the edges of Greenland you saw in that animation are melting now, and I think with further warming, we'll see increased melting there. I have not looked at specific projections. How much more melting you would experience would depend on how much warmer it gets. And so there are people that have studied that and have estimates of it. So we can look at projections of future Greenland melting and look at that.
Thank you, Kate. And so my next question is for you, Michelle. It's Jared on Twitch who asks, how close is your day-to-day working relationship with NOAA or USGS?
That's a great question. Very close. And I would say in the federal space, we work closely with many agencies because we all bring different solutions to the table. So, NOAA has an active responsibility for providing forecast, and we have active responsibility for providing research and data and information. USGS has a different, FEMA has a responsibility for responding to disasters. So there are a number of federal agencies that we work very closely with to bring all of our data and information together to protect the public, to protect our lives and livelihoods here on Earth.
Thank you, Michelle. And so I have my next question, Kate, we'll give this one to you. Throughout the show, we've talked about how climate change impacts hurricanes, tornadoes, wildfires, but we have another viewer on Twitch who wants to know, does climate change impact cloud types?
Could you say that again? Sorry.
Does climate change impact cloud types and, clouds
Oh.
and cloud cover and things like that?
Yeah, so changes in temperature and can impact cloud formation. It's actually an area that scientists are really interested in better understanding because clouds are one of the things that they have a big role in weather. They also have a role in climate. So the mission that Michelle mentioned, PACE, one of its components is looking at clouds and helping us better understand cloud formation and how they change.
That's great. And, we also have the GLOBE program where you can make your own cloud observations. That's open to anyone in the public to volunteer and input your cloud observations. So that is a NASA Citizen Science project that folks are able to join. All right. Our next question is from a viewer on YouTube who asks, roughly how many years does it take for a satellite to positively identify a change in the climate? And so yes, trying to understand the process that leads to the conclusion. Kate, why don't you take that one?
Yeah, that's a good question. So I think, you learn different things over different time periods. And so with satellites, the nice thing about a satellite is that we see for most of our satellites, they orbit the full Earth. So we can get a complete picture of Earth and we get near real-time information. So we can get, as soon as the satellite is launched, pretty quickly after that, we start to get data down from it. We can see things like extreme events. So we have, satellites that look at precipitation. You'll see on the screen now GPM. When you see that acronym, that's looking at precipitation. And so once we start getting data from that, we can see things like heavy precipitation events. If you want to see how climate is impacting things, then you want to look at a longer term record. So looking at how things change over time. And for some of our satellite missions, we have decades long records. And so we're able to look through those records and see how things have changed over time. So we have, for GRACE and GRACE follow-on, the ones that we were using to look at Antarctica and Greenland, we have more than 20 years of information. For sea level rise, we have more than 30 years of information. And for things looking at the land surface like lakes, trees, crops, we have more than 50 years. And so we can look through that record and see how things have changed over longer timescales.
Thanks, Kate. And so our next question is from Mattress03 on Twitch, who asks, how does El Nino impact European summers and or winters? Michelle, do you want to take that?
Okay. Sure. So El Nino and La Nina are natural phases in our climate. So El Nino refers to warmer than average temperatures in the tropical Pacific, and La Nina is the opposite of that. So cooler than average temperatures in the tropical Pacific. So these, both of these impact weather in really distinct ways. The one that sort of sticks in my mind because we're in hurricane season is they really impact, or La Nina really impacts, um, produces favorable conditions for hurricanes to thrive. So during La Nina years, we expect to see more hurricanes. And that's exactly why we forecasters have predicted more hurricanes for this season because our colleagues at NOAA predict when we go in and out of these La Nina or El Nino phases. And so they're predicting that we will be moving into a La Nina phase right at the height of hurricane season.
All right, thank you so much. We have time for one more question, and this is a great one for both of you. How is NASA's climate data available to individuals across the globe? Kate, we'll start with you.
Yeah, so all of NASA's data is publicly available. So you can get it for free wherever you are, just going, start by nasa.gov, and there are different data sets available there. But one of the things we're doing is working to make it easier to use and easier to find. So I mentioned earth.gov before. That's one of the portals that we have where you can see based on different types of impacts. If you want to learn more about wildfire, sea level rise, you can find different data sets there.
Yeah, and I'll just add that, as I mentioned earlier, we have more than 25 missions constantly observing the Earth, giving us tons of data and information. And one thing we're really, really good at is collecting data and analyzing that data, as Kate said. And we're getting better and better and better at getting that data and information into the hands of people who need to make decisions. And this is a really big focus of our Earth Action portfolio. And so that could range from farmers who need information about which crops to plant to city planners who are making decisions about where to, plant more trees and have cool spaces in their neighborhoods, or develop climate action plans and implement those plans, to our other federal agencies. There are lots of discussions about climate services now and the data and information needed for climate services. It's a really I think space that is much needed, and we're doing more and more in that area.
Yeah, and that is great to hear. That's great information. And for folks watching, you can also contribute your own Earth observations. We mentioned earlier the Globe Project, where you can submit cloud observations. That is just one example of a number of citizen science volunteer projects that you can do from the comfort of your own home. So to learn more, you can visit go.nasa.gov/citizen science. Kate, Michelle, thank you both so much for joining us today, to discuss this incredibly important topic.
Thanks for having me, Tahira. This was fun.
Thank you. And thank you all online for watching. To stay up to date on climate science at NASA, follow NASA Earth on Facebook, X, and Instagram. Remember, from the space, sky, sea, land, NASA provides detailed climate data and research to the world. All of this data, as I just mentioned, is freely available to anyone, and you can access this information and more at climate.nasa.gov. Thank you, and see you next time.